Okay, now we want to do part 3 of the lab, and this is going to be on refraction. So reflection was when light bounced off of something. So here was the mirror, the light comes in, and then it bounces off. So that's going to be called reflection. This time, what's going to happen is the light is going to go from substance number 1 into substance number 2. So this could be air, this could be water, this could be air, this could be a piece of glass down here. This up here could be the glass, and then this down here could be the air. So, but you got substance number 1, substance number 2, and then we still need to have a normal. So here is our normal, and then when it gets into this substance, it's either going to go in this direction or it's going to go in that direction. So it's going to change direction when it goes into this particular substance. Now, the direction it goes is going to be dependent on which substance is more dense. So we get into that in our lecture notes. But for right now, I just want you to see that it bends. And then later, we'll discuss about which way is it going to bend when it gets into the substance. So do you remember that for reflection, the formula was that the angle going into the mirror was equal to the angle that was coming out of the mirror. This time, the formula is more complex. So it's going to depend on what the substance is. So this substance, whatever it is, has a particular molecular structure. And then its substance is given by the letter N, which is going to be called the index of refraction. So the index of refraction of the substance, where it's coming from, and then instead of the angle, it's the sine of the angle. Now this is trigonometry. Ooh. So this is higher level mathematics than algebra. But you remember that on your calculator, if you look at your calculator, it has a button that says SIN. So that's the sine. And so it's the sine of the angle going in, and then it's going to be equal to the index of refraction of this material down here. So this can be out, or you could say N1 and N2, and then it's going to again be the sine of the angle coming out. So you notice that both sides have angle in, angle out, but it's a little bit more complex because it depends on the substance. Now we could even make these two formulas look a little bit more similar, because we could have the index of refraction going in and the index of refraction going out for reflection. But what do you know? It's the same substance. So if it's a mirror, this is air, and then it goes back into air. So that would mean that these two things are exactly the same, which would mean that they would cancel out. But if we wanted to do it that way, we could, but we're not going to. So this is a much easier way of looking at it. Now, if you were taking an upper level physics class, I would actually have you measure the angles and then take the sine of the angle and then actually use the formula. We're not going to do that, but I just did want to show you what the formula looks like. All right, so now we're going to go to the internet and find PhET bending of light, which I didn't do here. So let me go ahead and find that for you. So PhET bending. Okay, now we've got the intro, we've got prisms, and then we've got more tools. So we want to do the more tools one. So let's click on that. And so here's our picture. Now we've got a laser, or as Dr. Evil would say, laser. All right, so here's our laser up here. And then we can press the button, and you can see that here's light that's going from this substance up here into this substance down here. And you can change the substance. So you see that this one up here has an index of refraction of 1. And that turns out to be air. And then this one down here is going to be glass. But if we can change the index of refraction to other substances if we want. Now what we could do though is let's click on air, and do you notice what happens? So do you see that the light doesn't bend at all? It just keeps on going in a straight line. So that tells you you've got to have two different substances in order to have refraction. Okay, so let's go ahead and put it back on glass, and there's our light. So notice that some of this light is being reflected off of this surface, and then some of this light is actually going into it and it's being refracted. Now what was this line here called? So that was the normal. Now what I want you to do is to measure some of these angles, so that if you take this, so here's your protractor. Okay, now we need to put the protractor on there like that. Okay, now do you remember how did we measure the angles? So the angle is this angle right up here. So that would be the angle going into the material. And then this one over here would be the what? That's the reflected angle. And then you also have this angle down here. So this one would be the refracted angle. And so you're going to measure those angles, and then you're going to put them into a table. So down here, the incident angle is the angle going into the substance. Then you got your reflected angle and the refracted angle. So you're going to put those measurements right here. Okay, then you're going to, so let's go back to the lab, and you're going to click, I'm not going to do it for you, but you're going to click on this button down here that says angles, and then it's going to show you what the angles really are. And then you're going to put that in the lab. So then you will put that here for the actual angles. Okay, then I want you to try some different things here. So it says change the position of the laser, so that if we go back to the lab, you can grab the laser and you can move it. So the question is change the position of the laser and note how the refracted angle changes. Another thing I'd like for you to do is change the index of refraction of the lower substance and note how the angle changes. So in other words, refraction depends on the material that the light is going through. And then lastly, change the color of the light and note a very small change in the refracted angle. You almost can't tell, but as you change the color from red for the Roy G. Biv, so you got Roy, red, orange, yellow. So change the color of the laser, and then you'll see a very, very slight change in the how the light bends when it goes through it. And this is the principle of a prism. So the idea is that light, when it goes through a prism, because of the way that the prism is shaped, it will spread out the light into the rainbow of colors. And water will act like a prism, so that if you got a cloud that has each of the water droplets in that cloud will act as a teeny tiny prism, so that light, white light, when it goes through water droplets, will spread out the light into the rainbow of colors, and eventually that's what a rainbow is. So, done with part 3, and now we're ready for part 4. And so let's take a break, and when we come back, we will get to this.